Hey, well, welcome back. Our next discussion is going to be on air pollution. Uh, it's pollution of the atmosphere, usually the lower atmosphere, though pollutants have been seen at all levels of the atmosphere. Our troposphere, lowest layer of the atmosphere, extends up to about 7 miles. Thickest part of the atmosphere, it is also the area where most weather occurs, and it's where most air pollution is found. Now, air pollution, um, like other forms of pollution, it can occur naturally, it can be caused by man. Um, Natural sources of air pollution include particularly um, volcanic eruptions. Give an example: Cameroon in 1986, in West Africa. Volcanic eruption of hot gas at the bottom of a lake um, created hydrogen sulfide, and all this gas, this hydrogen sulfide gas, bubbled up to the surface and then floated downhill to this neighboring village. Um, and in the process, he killed more than 1,700 people. But even though we have this one example of air pollution occurring naturally, again, most of it is artificial. Man is responsible for a lot of it, and we have to take responsibility for our own actions. Now, just as the land has changed over time, so has the composition of the atmosphere. Um, until plant life developed, Earth's atmosphere was toxic to hydrocarbons, carbon dioxide, nitrogen, and so forth. But because plants respirate carbon dioxide and they, through photosynthesis, turn it into oxygen, um, the composition of the atmosphere changed greatly from being dominated by carbon dioxide to being dominated by oxygen. Today, the Earth's atmosphere is 78% nitrogen, into diatomic nitrogen, 21% oxygen, atomic oxygen O2, and the remnants are traces of carbon dioxide, CO2, water vapor, such as argon, krypton, among others. Now, subtle shifts in this balance can have extreme consequences, especially shifts in carbon dioxide. Remember our unit on weather, we talked about the greenhouse effect. There are certain gases that are better at trapping heat than others. Carbon dioxide is one of those gases. Um, helps keep it helps prevent heat from escaping into space. Now remember that some greenhouse effect is necessary for life on Earth, so we don't freeze to death at night. It's good to have some insulation, but too much of this gas can trap too much heat, causing all sorts of effects on the climate. Because remember, nature is in a careful balance, and if this balance is disrupted, it can have profound consequences one way or another. Now, air pollution comes in many forms, but the bulk of it comes from burning fossil fuels. Sources of primary air pollutants. $55% come from transportation. Cars, trucks, airplanes, what have you. $21% from combustion from stationary sources. Um, 16% from industry, manufacturing, and so forth. Some of these there's 21%, 16% part of it does overlap. You do also have combustion from certain types of power plants. 2% from solid waste disposal. Sometimes in the attempt to clean up trash, it does produce some, such as burning it, it does produce some carbon dioxide. Now, there are 6 primary air pollutants. Pollutant types versus pollutant sources. First one being carbon dioxide. Again, mostly from fossil fuel combustion. Now, they're useful products, but there's a price to pay with them. If too much of it, again, can cause serious consequences for the environment. Carbon monoxide, CO. While carbon dioxide can be poisonous in large amounts, carbon monoxide much more so. Is caused by the incomplete combustion of fossil fuels. So carbon monoxide is because the way it reacts with the hemoglobin in the bloodstream, it reduces the amount of oxygen in the body much more quickly than would exposure to carbon dioxide, a natural waste product of the body. 3HC, hydrocarbons. It's also from fossil fuel combustion, oil refineries, and petrochemical plants. Is oil refineries. Oil is a useful product, but it's transform it from oil into different products, different types of fuels, plastics, or lubricants. That's a messy process. And power plants, particularly coal and gasoline powered plants. Also, petrochemical plants. Petrochemical is chemicals based on with the oil as a base product. Many types of plastics and other certain types of chemicals. So you see kind of a common denominator here: carbon products. Nitrogen oxides, also from transportation and power plants. Now, carbon dioxide, carbon monoxide, and most hydrocarbons, they are colorless gases. Nitrogen oxide has kind of an orangish color to it. So it's ever a hot summer day and you're driving toward a large city like, say, Dallas, or particularly Houston, you see this kind of orange haze on the horizon. Those are nitrogen oxides. Or if you're in an airplane flying these cities, you may see this kind of orange haze over certain cities in the distance. That's those nitrogen oxides. Particulates. Include such things as car exhaust, refining, coal power plants, because of the coal dust getting in the air. Farming, construction, dust in general. Um, Dust is a pollutant, can cause serious breathing problems, such as nitrogen oxide can. But farming, particularly with harvesting, a lot of dust flies into the air. Especially if it's say a dry spring you just planted, a lot of dust can fly up in the air. Um, Construction, building buildings or repairing roads, building whatever, a lot of dust can fly up in the air. And six, sulfur oxides. Sulfur oxides are a combination of sulfur containing fuels, especially coal. Some industrial processes that will release sulfur oxides. It's estimated that more than 1 billion people, about 1.1 billion people, live in areas with unhealthy air. Um, One particular type of sulfur oxide, sulfur dioxide, um, is considered to be at unsafe levels for 625 million people around the world. Levels of dust are considered to be unsafe for um, about 1.2 billion people. According to the World Health Organization, about 3 million people die from air pollution causes each year. From unhealthy air, 3 million people will die. That is because of years of accumulation of problems caused by exposure to these different pollutants. Um, Asthma, lung cancer, emphysema, and just generally just the degradation of people who are already facing serious health problems of having to breathe in unhealthy air on top of that. Weather patterns can disrupt this. Rain can wash dust out of the air fairly easily. Um, Winds can kind of disrupt some air pollution, kind of disperse a little bit. But another type of a weather pattern that disrupt causes disruption is temperature inversions. Stationary level of warm, dry air will prevent warmer air from rising and cooling. That's locking in air into a particular area, allowing pollutants to build up, particularly in the valley areas. Usually lasts for a couple of hours, sometimes it lasts for days. This was a situation that happened in London just after World War II. A temperature inversion occurred, which led to all the pollutants in London basically locking in the city for several days. Pollutants just kind of car exhaust, industrial exhaust kind of built up, or in the middle of the day, basically people having to drive around with the street lights on, with their car headlights on. It's very difficult to see. And there were a lot of hospitalizations and deaths from this, just from a temperature inversion. This classic example of Los Angeles, it's kind of in a valley, kind of sitting in a bowl. So temperature inversions tend to lock in pollutants in the Los Angeles area very easily. That's in spite of its many air pollution controls in place. Just simply the atmosphere sometimes often works against it. Same thing in Mexico City. Mexico City is sitting in kind of a bowl, so the pollutants kind of sink in, and temperature inversions will kind of lock it in place for a while. Smog. That's another word we're using here. Combination of smoke and fog. Talked about a lot in the 1950s, 60s, and 70s in large cities. Particularly got photochemical smog. Got your nitrogen oxides, various kinds, combining with water vapor to produce nitrogen oxide, nitrogen dioxide. Now, nitrogen dioxide will then react with the hydrocarbon to produce ozone. Ozone, O3, triatomic oxygen. Saying oxygen, okay, it should be safe for us. This is a slightly different kind of oxygen. The chemical properties of ozone are slightly different than the diatomic oxygen you typically breathe. Small levels, it's not much, doesn't hurt much, but larger levels, it can cause breathing problems. And ozone, yes, it's very important for the atmosphere. The ozone layer helps protect us from ultraviolet radiation from the sun, but again, breathing in too much, which is a problem. Again, another example of nature, it has to be just right. Now, ozone pollution, that's a very serious problem. Generally produced in a more, because it's produced in industrial areas, and about 90 million people in the United States generally, their areas of ozone levels are considered to be beyond a safe level. Let's take a minute and talk about ozone, though. Because the thing about ozone is that while it is useful at protecting us from solar radiation, it's not going to rise to the atmosphere. It's a fairly unstable molecule, so it breaks down very easily. So producing ozone on the ground is not going to solve the problem with the ozone layer. Like I said, it's just too many problems, atmospheric dynamics, the instability of ozone, just wouldn't work. So the famed ozone layer. It's currently about 6 to 15 miles above the surface. It's not all ozone, just partial, fairly largely normal levels of it. In ozone, O3. And it shields the surface from ultraviolet radiation. Surface here, troposphere here, and then you got the ozone layer. Ultraviolet radiation hits these molecules and it keeps keeps ultraviolet radiation from getting to the surface, except at smaller levels. Ultraviolet radiation, that's what causes your sunburns in the summer. So without the ozone layer, that would cause very serious problems, increase in skin cancer, damage to crops, and so forth. This is what happens when you have problems with ozone is O3, ultraviolet radiation breaks up to oxygen and an oxygen ion. Basically, the ray of ultraviolet radiation breaks up the oxygen, and then it reforms again. But you have other types of radiation you're dealing with, and the upper levels of the atmosphere deal with those kinds of radiation. The X-rays and gamma rays, and higher level radiation in the upper atmosphere. The Earth's magnetic field deals with this as well. Now, the biggest problem with the ozone layer has always been something called chlorofluorocarbons. Always called CFCs. A whole class of chemicals known mostly as for aerosols and refrigerants. Some types of aerosol cans, they use these chlorofluorocarbons to make them work, spray whatever it is you need sprayed out, spray paint or whatever. And the problem is that CFCs rise to the atmosphere and they don't break down fairly easily. But generally, they do break down, but it takes about 7 to 15 years for it to break down. But then these CFCs rise up from the surface from our little factories here. And it disrupts the ozone. This is how it happens. Pick a chlorofluorocarbon. CF2Cl2, common refrigerant. Say carbon here, fluorine gas, chlorine gas, all mixing together in this one molecule, chlorofluorocarbon. All right, you got some ultraviolet radiation here, the ozone layer, and breaks up the atom. Suddenly you've got a free chlorine atom. It's got a negative charge. It wants to bring that charge back into balance. Well, And you got the next, got your ozone here, and instead of the means ultraviolet ray meets this negative chlorine ion, which breaks it down into oxygen. Breaking up the ozone molecule. So what happens is this little chlorine ion can bounce around back and forth and disrupt all sorts of ozone molecules, breaking up into these free ozone diatomic oxygen, these free oxygen atoms, which then combine with other oxygen or other substances up in the atmosphere, which means it's not able to absorb that ultraviolet radiation. Not like how like it's supposed to. So it breaks down very, very easily. Chlorine, in this case, acts as a catalyst. Catalyst in chemistry, remember, that's something that speeds up a reaction. Ozone is naturally going to break down. Chlorine just speeds up that process. It makes it more difficult for all the oxygen atoms to recombine back as ozone, thus making it increasingly difficult to block ultraviolet radiation from space. Now, problems of the ozone have been discussed since the 1960s and 1970s. But a hole of sorts with the ozone layer was discovered around the South Pole in 1985. Again, because of the weather conditions and the winds surrounding the upper level winds surrounding the South Pole, depletion of ozone occurs fairly naturally in the South Polar winter. And it generally recuperates during the summer as the weather patterns shift. Well, because of the increased presence of chlorofluorocarbons in the atmosphere by the 1980s, the ozone, the natural depletion of ozone in the Antarctic winter was accelerated. Levels of ozone dropped considerably. It's causing a lot of problems for the southern hemisphere. Increases in sun cancer risks, problems for crops. But through international treaties, chlorofluorocarbons were generally banned and phased out. Most of them, anyway. What happened as a result, over the next 30 to 40 years, the ozone layer in the Antarctic generally recovered. It's an example of an environmental problem that we were largely able to fix. Now, again, there are some natural disruptions of the ozone producing process at the South Pole, but it isn't as much of a problem because of the chlorofluor problems aren't really making the problems any worse. Now, another problem with ultraviolet radiation, not for crops, but increased radiation disrupting plant life at the surface of the oceans, which means the base of the food chain of the oceans is disrupted, which means all the animals feeding on, all the fish feeding on these plants, and the fish feeding on those fish, and so forth. They're disruptions of the food chain, disruptions of the population available food supply. It becomes a very serious problem. But a 1987 treaty to reduce chlorofluorocarbons by 90% by 1998 was met. Unleaded gasoline helped a lot of problems, helped solve a lot of these problems. On into the 1970s, many automobiles used a type of gasoline that had a lot of lead mixed into it as part of the refining process. And the engines, particularly the carburetors and so forth, were designed to process leaded gasoline, which meant car exhaust sometimes had a lot of lead particles flying through the air. But with the introduction of unleaded gas, particularly in the 1970s and the 1980s, it meant that the lead in these fuels was being phased out, and car exhaust was not as toxic as it had been before. By the early 1980s, unleaded cars were pretty much the standard in the industry. There were still a lot of cars using leaded fuel still around, but eventually even those were largely phased out, which meant that cars were not burning lead in their fuels and their exhaust, and car exhaust they were producing was generally cleaner, and that did help reduce air pollution to some extent in many larger cities. So since 1985, lead emissions have been reduced by more than 98%, almost entirely eliminated. Sulfur dioxides, another byproduct of many types of fuels, that has decreased by more than half since 1985. And carbon monoxide emissions have increased by a third since 1985. So a lot of progress was made on these issues, but still some things that needs to be kind of taken care of. Now you got the issue of land pollution. Talk about water pollution, talk about air pollution, talk about land pollution, surface pollution. Just simple litter and trash. The different types of this. For example, open pit mining. Usually trying to obtain iron, copper, sand, gravel, and stone. Open pit mining is basically cut a big hole in the ground and start sifting through it. What do you do this mine space after that? Pits are usually have to open after mining. It's a lot of dust, a lot of water pollution, and basically you got this big hole in the earth. Strip mining, usually with coal mining, sometimes with other types of ores as well. But basically, strip mining, dig these big trenches, and they just plow through these hills and mountains, try to get whatever kind of coal they can get out of it. Process, actually a lot of trash, waste, and toxic substances are left behind in the soil afterward. Solid waste, about 2 billion tons per year in solid waste comes from U.S. mining. They got the idea here of subsidence. Subsidence. Subsidence is the settling or grinding of the land. Now, sometimes mining has this effect. A lot of times it's caused by changes in the water table, but sometimes it can cause such things as sinkholes and so forth. And also gets us to the issues of habitat damage. Clear cutting of forests, a lot of waste left behind by that, but you also have the problem of a habitat damage. Litter and pollution, trash you see on the side of the roads. that's a problem when it's unsightly, but also there'll be toxic substances left behind, and this trash can often get into the water supply. And sometimes it can cause damage to the wildlife in the area. Now, what happens when population of a particular species is greatly reduced? They get to the point where they're considered endangered. Now, there are several different levels of endangered. Now, the endangered species means they're in danger of extinction in the wild. Now, basically, you've got 10 different levels of it. One is they call least concern, which means safe for now, but couldn't be, but could be hazards in the future. Threatened, this next layer of it, means there has been a significant loss in population, a significant loss in habitat, endangering the future ability of that species to survive. Then there's endangered. Basically, most of the members of this species are already gone. And severe, with endangered levels, you're in severe danger of the species dying out altogether. Endangered, next level is extinct in the wild. They aren't living out in the wild anymore. No one will be able to find them. This case, zoos and wildlife reserves are essentially the only places where these particular species will even exist anymore. And zoos and wildlife habitats, they do an excellent job of educating the public, but also keeping some species from going entirely extinct. So that's because these particular ones are cared for so well and so carefully managed and protected, given food and habitat. The only thing's keeping them alive. Man's activities may have pushed them to the brink of extinction in the wild, but a few people left are helping keep these few species going. And extinct everywhere, completely gone. Now, all this goes back to the importance of biodiversity in a particular ecosystem. Biodiversity, again, that's how many different species of plants and animals are in a particular ecosystem. The more there are, the healthier it is, which means an ecosystem can handle imbalances in food supplies and disruptions in population. They have enough other sources of food and energy and resources that they can adjust to the periodic imbalances and disruptions in the ecosystem. Now, by the year 2000, 24% of all known mammal species are threatened. Percent were critically endangered. Those threatened include 11 species of hoofed animals, such as rhinoceroses, zebras, and so forth. 65 species of carnivores, such as wild cats and wild dogs, bears, and so forth. Polar bear is considered to be endangered because of loss of habitat. Change in the polar and the North Polar regions, it's made it nearly impossible for many polar bears to be able to find food. Wild cats, lions, tigers, cougars, so forth. 70 species of ungulates. It includes deer, sheep, and so forth. And 96 species of primates. Variations on apes, monkeys, gibbons, and so forth. Human beings were primates. Example of the dangers here. Now, a lot of this is because of habitat loss, but some of it is because of being hunted to near extinction. One example, the black rhinoceros. 1900, they're estimated to be about 1 million. In a century, reduced to only about 2,500. %99 of the black rhinos are lost, putting it to critically endangered. Strangely enough, what they kill them for, their horn. People think crushed rhino horn is a aphrodisiac. There's no evidence of this. But nevertheless, people are being killed for it. Mountain gorillas, Central Africa. Down to about 650 known left in the wild. Mountain gorillas are very intelligent. The famed gorilla Koko was a mountain gorilla. She was extremely intelligent. She learned sign language, had a vocabulary of 200 words. It's a very gentle, very intelligent creature. Lived for many years at a zoo. Became world famous so well she could communicate. You'll tell, she had concerns. She was tell her when she was happy or hungry. She had a sense of humor. Very caring and nurturing. Lived a happy life until she passed away at a very advanced age. The white rhinoceros. Just one left. Basically, it's nearly gone. Out of nearly 10,000 bird species, about 1 in 8 are considered threatened. Elephants. There are now only 2 species of elephant left: the African elephant, the Asian elephant. Used to be several species of it. About a dozen at one time. But the elephants being reduced to extinction. Again, because hunters are trying to track them down for their ivory, leading to an international ban on the ivory trade. Those are being killed for their tusks. Another reason. And as a result of that, elephants went being from an estimated 5 to 10 million in 1930 to about 1.3 million by 1979. By 2005, estimated to be about 300 to 500,000 left. Numbers just keep going down further and further. And the thing about elephants is they're social creatures. There are some zoos that tried very hard to care for them. Elephants work best when they're with larger groups of other elephants. They just don't do as well without other elephants around, no matter how well they're taken care of by humans. About 270,000 plant species. About 1 in 9 are on the endangered list, threatened on down to endangered. China, India, Indonesia, and Brazil have the largest number of threatened species in the world. Those four countries. The United States has the largest number of plant species threatened. About 29%, about 4,700 out of more than 16,000 native plant species considered threatened. Again, largely because of development and habitat loss. China, India, Indonesia, and Brazil, large number of animal species threatened. About 2/3 of all species in the world are affected by loss of habitat. For example, in the country of Botswana in Africa, about 250,000 antelopes and zebras died within 10 years. This land has been cleared out to make room for a field for cattle to graze. You also have the idea of exotic species. Sometimes it's also known as an invasive species. Whether invasive or not kind of depends on its overall effect on the ecosystem. But an exotic species is a species introduced into an ecosystem that is not native to that ecosystem. For example, the introduction of rabbits into Australia. Few rabbits were introduced, and before long, because the rabbits are in a new environment, they don't have their natural predators to keep the population in check. Rabbits did what rabbits do. Population exploded. So many rabbits were being born, millions of them in no time at all. And it became a very serious problem in Australia because there's so many rabbits. The so-called Africanized bee, also known as the killer bee, was introduced into the U.S. Originally they were from Brazil, but they escaped from the lab, so they kind of worked their way up through the Americas into the United States by the mid-1980s. Again, these Africanized bees, the problem because they kill honeybees, which are so important for crops. Rabbits were causing all sorts of damage to crops in Australia. Another example of an exotic species, the horse. Horses are not native to the Americas. They were brought over originally by the Spanish conquistadors in the 16th century. And if you got loose, were fruitful and multiplied. And for long, there were whole herds of horses running across the plains across the western United States. Became an indispensable part of Native American cultures for the different tribes in those areas. But the introduction of new species, again, can cause a serious disruption for the existing species. Biomagnification. We talked about this earlier. The collection of toxins from building up within animals over time. And certain types of toxins, chemicals, insecticides, herbicides, they don't break down easily. So what happens is, as more and more animals eat smaller animals or plants contaminated with herbicides or insecticides, it'll simply collect in their bodies, building up more and more. And the larger animals eat these smaller animals. They absorb these chemicals, which builds up in their body more and more. And on down on the food chain. The chemical DDT, again, was one of the most notorious culprits. damaging the eggs of birds, causing the shells to become so thin that sometimes they break open before they're ready to hatch. I mean, they couldn't have no more baby birds. But DDT, because that was banned in the United States by 1977. Other types of chemicals, such as certain types of PCBs, mercury, chlordane, as a herbicide, and other pesticides and herbicides cause serious problems with biomagnification. Hazardous waste. Discarding materials may cause subsidences, cause ground soil problems, causing other environmental problems, and also problems in human health. 3 major solid waste deposits. Way of disposing of solid wastes. Solid waste disposal. 3 ways to get rid of it. Landfills, just dump it somewhere. Got the county dump here smack over. Incineration, just burn it. In fact, some people actually used incinerating a solid waste as a way of producing power. Use it as fuel for power plants. Problem is, it's not always the cleanest kind of a power plant. And recycling. Many things we have can be recycled. It is broken down and reused again. Paper, aluminum, rubber. Many times oil can sometimes be recycled, so forth. Now, for landfills, you got a serious problem is possible groundwater contamination. And sometimes you have a big pile of solid waste. What happens is this waste is decomposing. And what happens in the decomposition process? Basic chemistry. Part of decomposition, heat is generated, chemicals or gases are released, and so you got more heat, more gas building up, which means sometimes this solid waste can actually catch on fire by itself. Sometimes they have to stick poles into these big piles of landfill waste so gases can have means to escape so it doesn't explode. So that is a problem with it. You can't just throw it away somewhere. Something has to be done with it. But there's no such thing as free lunch when it comes to nature. The groundwater contamination is the biggest problem. What happens when wind blows it around or it's you have a very high water table? A landfill, this is how 71% of solid waste is disposed of in the United States, just dumped in a landfill. Incineration, about 16%. And while it does get rid of the immediate problem, all you have is ashes afterward. The problem is, what is some of this solid waste made out of? It can, some of these items can contain high levels of arsenic and other substances, zinc and so forth, certain types of metals that can cause particulate pollution in the atmosphere. Recycling, that's the rest of it. Probably about less than a quarter of everything disposed of by recycling. But consider this, 13%. But 60% of aluminum cans, 40% of paper products, 25% of glass can be recycled. And much of it is. Many cities have recycling days. They can separate your garbage and it'll be picked up and brought to recycling centers in the city. Some cities just have common recycling collection centers. Some states have to recycle glass or aluminum that they collected and actually sell it back to these places that'll buy it. Then you got the other problems. What if it glows in the dark? Radioactive waste. That's a special problem. But low-level radioactive substances, it decays to a safe level about in under 1,000 years. Again, depending what it is. It could be a few decades to a few centuries. That's still a very long time, and exposure to it is still very dangerous. High-level amounts of radioactive waste, it could take 10,000 years or more of radioactive decay for the radiation to be reduced to safe levels. Example, plutonium-235. Mess up take about 240,000 years for it to be reduced to a safe level. Now, plutonium-235 is usually produced as a byproduct of producing nuclear weapons. And about others, and you have other radioactive waste problems dealing with fuel rods for nuclear reactors. Nuclear reactors are very efficient, but the fuel is very dangerous. What happens when you can't use those fuel rods anymore? And about a third of nuclear reactor fuel rods have to be replaced annually. And problem, where do you put it? You have to put it in these large concrete reinforced caves where nothing can get in or get out. Radiation can't get out. It's relatively safe, but probably have to find a spot that is far enough away from a population, far enough away from a groundwater supply, and far away from areas of seismic activity. You don't want earthquakes breaking open your concrete canister with releasing all that radiation. So there aren't a lot of places where that can be done. So that's an issue that people are still working on. But pollution, 3 major types of it: land pollution, air pollution, water pollution. Serious problems. You have serious problems for the environment, for the animals, for our water supply, for human health. But we're not helpless. These are problems that can be fixed over time with proper planning and proper innovation. So that's it for now. Next time we'll continue on talking about soils.